want to know, before we start, what this thing's gonna do. I want, how far ahead, what's gonna happen. I want to know that when it goes wrong, I'm getting my beer.
The timing should be pretty slow.
All right, Peter, show me.
Drive that way for 7 seconds, rotate for 9 seconds, drive this way for 7 seconds.
It'll drive straight this way. So around up here.
For 7 seconds.
Do a 180 degree turn.
Hold it. 7 seconds?
That's the one that drives forward.
I can run faster than that. I'm old.
Wait, I don't want it to go too fast forward, so say that.
It'll drive back to the starting location. Do another 180 degree turn.
They designed it from inside. I can catch up.
Yeah. Okay. How about stretching it just a little bit? Like instead of here, why not?
Come on, dude.
Almost bent out. Yeah, I'm divided.
When you go to McGinley's, I'll buy you the most expensive bottle of beer in the joint.
That's not tomato, that's next year.
It's a bar in Oklahoma. I talked to him, how expensive that could be. The attachments and all, they designed a 3D print themselves, which was kind of neat. And Joe, why don't you come point out the different things while waiting for Carver to get his control system going.
Okay.
I'm gonna interview you, dude.
All right. So we got right on these motor shafts. We have these motor encoders, and we ordered 1/2-inch encoders because that's how big the shaft are, but on them there's just this little plastic piece that's slightly smaller than a 1/2-inch diameter. So we had to 3D print a part that would fit onto the shaft and then come out and narrow just a tiny little bit so it could fit into the encoder properly. And then we have those mounted right here. We have, in this box, we have our differential GPS system that we were trying to get working. So there's those two modules right there. And they are connected to the antennas up here, which have, these are magnetic, so we put in a little magnet right here so these stick on properly. And we located them right here so that they could be right over the center of rotation, since this is using tank drive, because that makes it easier for the control scheme to operate on their feedback. And then we have our motors here. Motor controllers are in this box. Raspberry Pi is here that's doing our control loop. This is a battery that's going for the Raspberry Pi and the encoders. This battery is for the motors themselves, and then this is our a switch for our emergency brake.
What about these things out here?
Oh, okay. So then we have our LiDARs right here, which is going to be, once we have it incorporated into the control scheme, is going to be spinning right here, so it's for obstacle detection out in the front. And then for these, we have proximity sensors that are going to be pointing out in the front and the sides, on the front and the back, and we have those parts, and those are we're about to get those wired up into the Raspberry Pi for.
Would this be a mechanical switch, or what sort of proximity?
They're time of flight laser sensors.
Oh, okay.
And so they're going to be angled 45 degrees at the ground. So that's mostly for if you're come up to a step. If they're continuous, so they run, if they're measuring like 300 millimeters, it'll measure that within within about 5 millimeters, and then if you see like a 300 millimeter spike, then you know there's going to be, you're coming up to a curb or you're down a curb or something, so you can stop and avoid that.
These coax are your GPS antennas, or? These two?
Yeah.
Yes. Yes.
All right, Sam, take us over the communication system.
Yeah, so this is the hologram USB modem, so it connects to the cellular network. This is a pig talk that we were originally going to use for control.
Yeah, it's
but-
actually not doing anything now. It's just turned on, so
It's the blade.
program.
Yeah.
it's providing the
Yeah, the
power
program
to
doesn't
the-
start without it.
Yeah, so we can, when it's running, it can send GPS data via the RF antenna to a laptop if we wanted to. I would need to have the USB plugged into the other antenna. So, yeah, but essentially we just extended the antenna because that's the antenna module right there.
So which is the GPS antenna?
This is the one that
GPS,
comes
these
with
are
the
the-
Pixhawk.
these are the GPS
and those are
antennas.
the, yeah, different.
So it's running from the box.
Yeah.
Are you guys trying to fix a flat on that tire with that tape?
No, that's your timing because.
Measuring a full cycle, yeah.
Actually, it's in my point.
Yeah, we want the optimal path. All right, all right, Cara, this is it.
Let's go for it.
All right, do it,
Yeah.
okay. Do it in 1, no problem.
Uh-huh.
You do it in 2, cheap beer. Do it in 3, expensive.
Right.
All right, test started.
We had about a 66% success rate earlier. Right, that's
It's
right.
nice to have your level of confidence to multiple places past the decimal
Well,
point.
66%, at least you're gonna do a cheap beer, so let's go.
All right, 3, 2, 1.
I mean, I don't know what the 40 or days share that.
Yeah.
It's going to the left, go left.
Oh.
I added some time for you too, so.
I watched it where it goes on the turn.
0-point turn.
Oh!
Make sure I didn't do any typos.
Okay, it now became the expensive beer.
Have I told y'all
Yeah,
that
those are the right
$10
values.
bottle beer?
I didn't do any typos this week.
Is the chassis an original creation?
Alright, we'll try to improve it in real time, I
No,
guess.
that's one
So
that
under
Dr.
rotated
A
there,
used
so let's
years
add
ago in his-
another
his
second on the
Honda
rotation, I
Civic.
guess, because that was a
It
big
got
part of the
thrown out,
rotation.
but one of our students is a little bit of a pack rat, and we got it back.
It's a student who took after me, doesn't throw anything away. And case in point, it actually worked.
Yeah.
Okay.
Alright. I'm changing a couple. It'll have me input, alright, set 6 different parameters for like how long it rotates for, what speed it rotates at, the right offset. And when it,
We're already up to a cheap beer.
alright, let's go again.
But you like this all the time.
Oh, yeah.
Now you know why y'all like it.
It's not.
It's ready.
All right.
Until our day comes along.
I think the right offset's off again. They were the original last time, except for I added some time since he lettered it to go farther.
Oh, this is better. It is better. Come on, dude. Turn. Stop. Oh, nice. Nice.
All right, now you're off the hook.
Not cheap beer.
All right. Where's the best team? Best team, you guys know what you have to have done by the 23rd.
Yep.
No excuses, no matter what, right?
Yes, sir.
All right. Ground vehicle team, you know what you have to do for the 23rd. It's got to go outside, it's got to do a route. In fact, it's got, right? No excuses.
We have the test maneuvers too, right?
I don't care. If you go out and do the route, I'm happy.
Okay.
Okay?
All right. Focus on that.
So, that's it. All right?